Imagine standing before a mirror that does not show your reflection. Instead, it reveals fragments of the ancient universe itself. Not the present. Not your world. But light that began its journey billions of years ago, crossing an expanding cosmos long before Earth existed. Every faint signal arriving from deep space is a message from the distant past, preserved across unimaginable time. This is the purpose of the James Webb Space Telescope. It was not built simply to observe distant stars or capture beautiful images of galaxies. It was designed to look backward through time itself, to study the earliest moments of cosmic history and witness how the universe transformed from darkness into structure. According to modern cosmology, the universe began around 13.8 billion years ago in an event known as the Big Bang. In the beginning, the cosmos was unimaginably hot and dense. Space itself expanded rapidly, cooling as energy condensed into particles. Eventually, atoms formed. Hydrogen and helium filled the young universe like enormous invisible oceans drifting through space. But despite all this matter, the cosmos remained dark. There were no stars yet. No galaxies. No planets. Astronomers call this era the Cosmic Dark Ages. For millions of years, the universe contained only scattered gas and faint radiation left behind from the Big Bang. Slowly, gravity began pulling matter together. Tiny fluctuations in density grew larger over time, collapsing into dense regions where the first stars ignited. Those stars became the engines of creation. Inside their cores, nuclear fusion forged heavier elements. Their light pierced the darkness for the first time. Around them, the earliest galaxies slowly began to form. At least, that was the expectation. For decades, scientists believed the young universe should appear simple and chaotic when viewed far enough back in time. The first galaxies were expected to be small, irregular collections of stars still struggling to organize themselves. Complexity, according to theory, should have taken billions of years to emerge. The deeper humanity looked into space, the simpler the cosmos was supposed to become. But when the James Webb Space Telescope began observing ancient regions of the universe, something unexpected appeared. Where older telescopes saw only faint smudges of light, Webb revealed astonishing detail hidden within ancient photons. Galaxies once thought to be primitive suddenly appeared far more mature than expected. Some showed clear rotating disks. Others possessed dense central regions surrounded by organized star systems. A few even hinted at spiral structures, patterns scientists believed should not have existed so soon after the Big Bang. At first, researchers questioned the measurements. Distances in astronomy are estimated using redshift, the stretching of light caused by the expansion of space. If those calculations were wrong, perhaps the galaxies were younger and closer than they appeared. But observation after observation confirmed the same result. These galaxies were real. And many of them existed only a few 100 million years after the birth of the universe. In cosmic terms, that is astonishingly early. It was like discovering massive cities in a world where only the first foundations should exist. The universe appeared to have developed structure far faster than current models predicted. The deeper Webb looked, the stranger the story became. By studying the light from these ancient galaxies, scientists could analyze their chemical composition. The results introduced another mystery. These early systems already contained heavy elements like carbon, oxygen, nitrogen, and iron. Those elements are not produced in the Big Bang itself. They are forged inside stars and scattered into space when stars die in powerful explosions called supernovas. That process takes time. Stars must form, evolve, collapse, and explode before heavy elements can enrich the cosmos. Yet somehow, these ancient galaxies already possessed surprising chemical complexity. This suggested that the early universe may have been far more violent and active than anyone imagined. Stars may have formed rapidly, burned intensely, and died in enormous numbers within a relatively short cosmic period. Instead of slow evolution, the young cosmos may have experienced an era of explosive acceleration. And the mysteries were only beginning. Among the most puzzling discoveries made by the James Webb Space Telescope are enormous black holes appearing far too early in cosmic history. Modern theories suggest that black holes grow gradually over immense stretches of time. Small stellar remnants accumulate matter, merge with other black holes, and slowly become larger over billions of years. But Webb discovered evidence of supermassive black holes existing when the universe was still extremely young. Some appeared to contain millions or even billions of times the mass of the Sun only a short time after the Big Bang. According to existing models, there simply should not have been enough time for them to grow so large. Scientists are now exploring new explanations. One possibility suggests that certain black holes formed directly from massive clouds of collapsing gas in the early universe, bypassing the slower stages of growth entirely. Another theory proposes that unknown interactions involving dark matter may have accelerated the formation of galaxies and black holes alike. But none of these ideas are confirmed. And that uncertainty is what makes Webb's discoveries so important. The shapes of early galaxies raise even deeper questions. Instead of appearing chaotic and disorganized, many ancient systems look surprisingly ordered. Symmetrical disks, stable structures, and coherent formations emerged at a time when the universe should have been turbulent and unstable. It almost seems as if invisible forces guided matter into organized patterns far earlier than expected. Dark matter may hold part of the answer. Although it cannot be seen directly, dark matter makes up most of the mass in the universe. Scientists believe it forms an invisible framework surrounding galaxies, shaping how ordinary matter moves through space. But Webb's observations hint that dark matter may play a far more active role than previously imagined. It may influence the architecture of the cosmos itself. Long before visible stars fully formed, unseen gravitational structures may already have been sculpting the universe from within the darkness. Yet perhaps the most profound discovery involves neither galaxies nor black holes, but chemistry. Webb has detected complex carbon-based molecules drifting through interstellar space billions of light-years away. These molecules are considered important building blocks for life. That means the ingredients necessary for biology existed astonishingly early in cosmic history. Long before Earth formed. Long before the Sun existed. Long before any living organism emerged to observe the universe. The implications are extraordinary. It suggests that the chemistry of life may not be rare or isolated to one planet. Instead, the cosmos itself may naturally produce the ingredients required for life wherever conditions allow. The deeper Webb looks into the universe, the more reality challenges human expectations. Instead of a simple progression from chaos to order, the cosmos appears strangely organized from very early moments. Galaxies emerge faster than expected. Black holes grow impossibly large. Chemical complexity appears almost immediately after the first stars ignite. Every answer creates new mysteries. Every observation reshapes humanity's understanding of existence itself. Perhaps the most humbling realization is this: every photon captured by Webb began its journey billions of years ago. Those ancient signals traveled across expanding space long before Earth formed, carrying with them a record of cosmic history. Now, after crossing unimaginable distances, they arrive here. At a small world orbiting an ordinary star. Observed by a species that evolved briefly in the vast timeline of the universe, yet somehow learned to build machines capable of looking backward through time. We created a telescope to understand the cosmos. Instead, the cosmos revealed how little we truly know. And somewhere within that ancient light, hidden among the first galaxies, the earliest stars, and the darkness between them, the real story of the universe is still waiting to be discovered.